Discriminant and nature of the roots. At the end of the session, the students can now characterize the roots of quadratic equation using the discriminant. Describes the relationship between the coefficients and the roots of a quadratic equation. The value of the expression b squared minus 4ac is called the discriminant of the quadratic equation ax squared plus bx plus c is equal to 0. This value can be used to describe the nature of the roots of a quadratic equations. It can be 0, positive and perfect square, positive but not perfect square, or negative. When b squared minus 4ac is equal to 0, then the roots are real numbers and are equal. Example, describe the roots of x squared minus 4x plus 4 is equal to 0. The first step is to find the value of a, b, and c, which is a is 1, b is negative 4, and c is 4. The next step is to substitute the value into the discriminant, which is b squared minus 4ac. The value of b is negative 4, and the value of a is 1. The value of c is 4. So let us now simplify it. Negative 14 squared is 16. 4 times 1 times 4 is 16. So 16 minus 16, that is 0. So it says here that when b squared minus 4ac is equal to 0, then the roots are real numbers and are equal. Now when b squared minus 4ac is greater than 0 and a perfect square, then the roots are rational numbers but not equal. Example, describe the roots of x squared plus 8x plus 12 is equal to 0. So let's find the value of a, b, and c, which is 1, 8, and 12. Let us now substitute the value to the discriminant b squared minus 4ac. So the value of b is 8. The value of a is 1. The value of c is 12. So let us now simplify it. 8 squared is 64. Then 4 times 1 times 12 is 48. 64 minus 48 is 16. So it says here that when b squared minus 4ac is greater than 0, meaning to say all positive numbers, and a perfect square. So 16 is an example of a perfect square. Okay? Then the roots are rational numbers but are not equal. Now, when b squared minus 4ac is greater than 0 but not a perfect square, then the roots are irrational numbers and are not equal. Example, describe the roots of x squared plus 7x plus 5 is equal to 0. Again, find the value of a, b, and c, which is 1, 7, and 5. Let us now substitute it to the discriminant, which is b squared minus 4ac. So b is 7, a is 1, and c is 5. Let us now simplify it. So 7 squared is 49. 4 times 1 times 5 is 20. So 49 minus 20 is 29. So it says here that when b squared minus 4ac is greater than 0, meaning to say your answer is positive numbers but not a perfect square. So 29 is an example of not a perfect square. Okay? Then the roots are irrational numbers and are not equal. Now, when b squared minus 4ac is less than 0, then the equation has no real roots. Example, describe the roots of x squared plus 5x plus 8 is equal to 0. Find the value of a, b, and c, which is 1, 5, and 8. Let us now substitute it to the discriminant b squared minus 4ac. when b is 5, a is 1, and c is 8. Let us now simplify it. 5 squared is 25. 4 times 1 times 8 is 32. So we have 25 minus 32 is negative 7. So it says here that when b squared minus 4ac is less than 0, meaning to say your answer is in negative number, then the equation has no real roots.